You're going to be asked in the homework, what are the variables and how do they relate? Okay. When they ask you how do they relate, they're saying what's the relationship between these two things? Basically what you're looking for with these is as this one goes up, the other one goes down, or the temperature rises as the time increases. So you're going to be talking a lot about like rise and fall or increase and decrease in your responses for these things, but all based on some graph that you see, some visual image, some visual representation of things. So the first example that I'm going to give you here, you can just draw this graph with me. This is what would be given to you. Okay, so you can kind of think of it like a coordinate plane. This is just quadrant what? One. This is just the first quadrant if we're looking at it like a coordinate plane. This would be our 0. This bottom section represents time. And then the left side over here represents the height of a tree. Okay? And here's what my graph will be. It's kind of squiggly, sorry. Pretend that's a straight line. Can anyone tell me in words what that graph is saying to you?
It's going up.
What's going up?
The height of the tree
Over time, right? So as time increases, the height of the tree increases, right? So if we were to just put some numbers in here, we're not going to put numbers in. You don't need to write numbers in, but I'm just going to kind of give you a visual here. So let's say this was 1 year, 2 years, 3 years, 4 years, 5 years, 6 years, right? And this was 10, 20, 30, 40, 50, 60 feet. Okay, well, after 1 year, the tree is 10 feet tall. After 2 years, it's 20 feet tall. It must be the California redwoods here with as tall as this tree is going to get. But basically what we're saying is as time increases, the height of the tree increases. Okay, so you can say that a lot of ways, but, well, let's do this. As time increases, oh, you're back. The height of the tree increases. Okay, but like I said, you can say it a lot of ways. So you could say it that over time, the tree gets taller. Okay, that would be another way to say it. That would be very acceptable. Does that make sense? So you're just looking at a graph and seeing the variables. So they'll give you this and this. Those are considered your variables. And you're saying, how do those two things relate to each other? Okay? What would this one be then? Example 2. If I give you this side over here is the air in a balloon. And this is time. Okay, I'm going to give you the graph for this one, and then we're going to fill in the different pieces of the graph. So, because this graph changes how it looks, it's not just a straight line. So we're going to label each piece of it. Okay, but here's what the graph looks like. Okay, so the red is representing the air in the balloon over time. So I want you to stop and think about that. How much air is in a balloon over a given period of time? And think about, can you figure out what's happening in each section of that graph? Can anyone tell me what you think is happening right here? The air is increasing, okay? But like, think actual situation. How is that air increasing, do you suppose?
It makes it bigger. You go up.
More air, right? So you're blowing into the balloon,
Okay.
can we say? Yeah? So what's happening here? The air is staying the same. So what happened? You're taking a breath, right? So you think about when you blow up a balloon. You pinch, you take a breath. No more air is going into the balloon right there, right? So what's happening right here? You're blowing air into the balloon again. And what's happening here? You're stopping to take a breath. And what's happening here? You're blowing air into the balloon again. And then what?
You're going down.
It popped, right? Because you went from full of air to zero air in no time. The balloon popped, okay? So we're going to say, this is what you'll do with these ones, okay? Where you have to like tell each part. Just point an arrow to what it is. So blowing into the balloon. Okay. And then this one, and I'm just going to do this because they're the same thing. We're going to say stop to take a breath. Don't stop breathing. No, that's not what we want. And then I'm just going to draw this arrow here and here. If you do arrows, just make it very clear which arrows are where. Maybe you want to write the one inside here and go arrow, 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 if that makes it clear. I don't care about that, but what? Or different colors would be good. And then this one, we're going to say the balloon pops. So just try to be really specific as to what is going on. Don't just say more air, no air, more air, no air. Like, explain to me. Well, if that's the case, what do you suppose is happening? You're blowing up a balloon, right? So blowing into the balloon, stopping to take a breath. Blowing into the balloon, stopping to take a breath. Questions on that? Okay, now we're going to see if you could draw the graph. So I'm going to give you words and see if you can come up with this graph on your own. And then we'll do it together to make sure that we got the right graph. Bear with me on the wordiness here, but you got to know all the details. So it says a model rocket blasts off until fuel runs out. Comma, here's the next part, starts to drop rapidly a parachute deploys and then it falls gradually to the ground, usually somewhere into the ocean, I feel like. All right, your job, first of all, can you tell me what our two variables will be? Let's set that up together. So let's say we have this, okay? This part of it, if there is time involved, this is time, okay? So for this, we're saying over time, a model blasts off, goes till it runs out, all that. So this is going to be your time, okay? Any thoughts as to what the vertical axis will be? The what? Not the fuel. I see why you say that. How high the rocket goes. Okay, so this is going to be the height of the rocket. Okay, so what I want you to do is just think about, break that down. It blasts off until fuel runs out. What's that going to look like? Starts to drop rapidly. Where does the parachute deploy? And then how do you show it falling gradually to the ground? So you should have kind of four distinct things that you could write something about. See if you can lay that out and then we'll lay it out together. And every graph is not going to look identical, and that's okay, because the speed of your rocket might be different than the speed of somebody else's rocket, right? But they should be similar, at least. Okay, let's think about this. What's the first thing you drew? Going up.
But go around halfway and then circle and then.
Okay, so we're gonna shoot the rocket into the air, right? So this is our rocket launches. Okay. It says until fuel runs out. So then it starts to drop rapidly. So we went up rapidly, right? Now we're gonna drop rapidly. So at about the same slope here would be our drop. And then it says that the parachute deploys. So this point right here is where we're gonna deploy our parachute. Where do we go from there?
No.
We go down, like this.
No.
How do we go down?
Like,
Right, a little more, less of a slope, right? Because we were falling fast, but then when you deploy your parachute, you're gonna fall slower. So it's gonna take more time, right? Time's going this way. So it's gonna take more time to get to where we wanna go. So it's gonna do something more like this until it hits the ground, right? And here's our ground level over here. So this is falling slowly or gradually. Okay, so the rocket launches, starts to fall fast, and then they deploy the parachute, and then it falls really slowly from there. Okay? Questions on that? Did anybody's look kind of like that? A little different? Just the thing that you have to make sure of is if the rocket shot up and it's falling, right, it's not going to go back up again. So everything should be on its way down on that other side. It's just a matter of you might have yours at a different slope than I do, and that's okay. Okay? Questions on that? Okay, last thing we're gonna do, I'm gonna give you a chart to work from this time. And this is our last example. So let's say we have time on top and temperature. Which one's gonna be our X? The time, right? This is gonna be our X, this is gonna be our Y. So we're gonna say this is 1 p.m. This is 3 p.m., 5 p.m., and 7 p.m. Okay, and then temperature, so at 1 p.m. it is 61 degrees, at 3 p.m. it's 62 degrees, at 5 p.m. it's 58 degrees, and at 7 p.m. it's 51 degrees. All right, so if we're gonna lay out a graph of this, we said our x-axis is gonna be our time, and our y-axis will be our temperature then. Okay, this is always 0, 0, right? So if we're just going from 0, this is kind of a weird way to think about it, but we're gonna say 1 p.m. is here, 3 p.m. is here, 5 p.m. is here, 7 p.m. is here. Okay, so 1, 3, 5, and 7. And then temperature-wise, let's say we'll count by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. Sorry, that's really messy. That's a 60. That's a 55. Okay, so where does this 1 p.m. 61 degrees, where does that fall? Directly above which number on the bottom here? Directly above the 1, right, at 1 p.m. And then you just need to go up to 61 degrees. So that would be maybe about here. Then you go to 3 p.m., it would be 62 degrees. That's barely above our other one. Okay, at 5 p.m., my spacing here is not great. It would be 58, so that's going to be a little bit below again. And then at 7 p.m., it's 51. So here's my question. Is that our graph?
No,
Why not?
because you need to connect the one.
You need to connect it because there is a temperature at 115 or 2 or 203, right? There are temperatures there. So what we're doing is temperature's not going to go like super high and then drop super low. It's not like we're going to go like this in between, right? It's going to be pretty gradual of a line. So our temperature would look something like this, and we don't know like the low that it drops to, but we stopped here, so you don't need to go any further than what is shown in our graph, but that would be a good representation of our temperature over time. Okay? Questions on that?